Hi, I'm just going to introduce the histology content with the instructions on what to expect on exam 1. Okay, so let's start with naming this tissue. This is called simple columnar. It's simple because it's single layered. There's one cell that has exposure to an external cavity or and it could be an internal cavity, but it would be the hollow part of it. And then the basal surface is attached to a connective tissue here, and we have one cell adhered to the connective tissue at the basal layer. So that makes it simple. It's columnar because it's long. Simple cuboidal we have here, and this you see these shapes are somewhat square-like or three-dimensionally would be cube-like. They're a single layer again, making it simple. And we also have the connective tissue layer just below. Again, notice how the apical surface is exposed to a hollow, an opening, if you will. Okay, so this is transitional epithelium. This is from the urinary bladder. So when you see this slide, you'll identify it as transitional. Transitional cells appear to be cube-like when the bladder is empty, and then as the bladder fills and those cells stretch and open with the fluid in the bladder, you get that squamous-like image. So here you can see that the bladder isn't full and that you have more of a cube-like shape, right? These are very round nuclei. As this starts to stretch, those will start to look more squished like that particular cell in the nucleus. And this is called transitional epithelium. And when you have this slide on the exam, you can write transitional and you're done. Simple squamous, okay, so this is frog's tissue, and it looks like a fried egg here. This is a coronal view looking down in that coronal section versus if we were looking at it this way, right? If we had cut the cell and looked at it, it could appear more squished. So it's not a great example for squamous, but this is a single layered squamous cell. Deep to this, there is a connective tissue layer and no other cells. Simple, one layer. Squamous is going to be that more squish-like appearance. Pseudostratified columnar. So this tissue has microvilli or cilia, which is a brush-like border here. And it is pseudo means false, P-S-E-U-D-O, pseudo. It's false, multiple layered columnar cells. So they're long, elongated, making them columnar. They're falsely stratified because one cell is adhered down to the basal layer. Although it appears to be that there's cells on top of one another, each cell here is adhered down to the basal layer, making it a simple or a single-celled epithelial tissue. Doesn't look like that, so it's falsely stratified, pseudo-stratified columnar. Stratified squamous, multiple cells. So you have multiple cells here before the connective tissue layer. And what I need you to imagine is that the connective tissue is where this is adhered down. Here's the apical surface, right? So because there's multiple layers and the apical surface are the squished look like cells, this is stratified squamous. Down here, they still look pretty a little squished, but they start to look cuboidal at some point, right? However, because it's labeled by the apical surface, or it's named by the apical surface, we use these shapes of the cells to identify it. This is an example of a stratified squamous. Adipose tissue is lipid, fat. So this lipid cell pushes the nucleus to the side of right here, is the nucleus gets pushed to the side of the lipid or the bubble. So this is the cell membrane with lipid in it. Adipose is fat tissue. Elastic tissue, in the dye here, we see these black-like lines. Elasticity means that it will be able to stretch and then return to its original place. This is elastic tissue. Here we have bone. there's a central canal here, and in bone development, you get these rings that are characteristic of what bone looks like at the microscopic level. This is blood. These are red blood cells. Blood is a connective tissue. Another connective tissue here, this is dense regular. So I think of tendons when I think of this, and this is dense because there's not a lot of matrix or background substance, and this is regular because these lines are parallel, okay, and it's a connective tissue. Reticular is somewhat elastic, which are these elastic fibers that you see here, and unlike the tissue we saw as elastic connective tissue that kind of gets pulled in one direction, this is more like a webbing of a net, so it kind of has this elasticity in a circular or multi-dimensional way, as opposed to a pull between two tension points. So this is called reticular. Loose areolar is beautiful. It has a lot of ground substance, so that would be the fluid in which these fibers and cells are located, the ground substance. So that's why it has this airy kind of look to it. Here we see the cells, and then it has elastic tissue running through it. Loose areolar. Now we're into the cartilages. Fibrocartilage. Fibrous is dense. It happens to be dyed blue, so when you see it, you'll be able to recognize this slide as fibrocartilage. Still, we do have mostly it's going to be the dense cartilaginous tissue, right? But and what we don't have, right, is that ground substance with cartilage. Here you get a little bit. This has a shiny appearance. This is hyaline. Hyaline is located at the ends of the long bones, so it gives your bones a slippery, glossy effect. It gives it a look that's slippery and glossy, but it also looks like that on the microscopic level, and that allows our shoulder joint to move smoothly. Here's more elastic cartilage, so you have nice visions of cells, and here again, the dyed black is that elastic tissue fiber. So elastic cartilage is in the nose here and in the ears, and it just has a bit of flexibility, but still maintains cartilage properties. Cardiac muscle is this one. It is easily identified by these intercalated discs. So between cells, there's a collated disc. So cardiac muscle has a very specific way of contracting, and its form and function operate together. So we'll look at that in more detail, but this is cardiac muscle tissue. Just a side note, once this tissue dies, it doesn't regenerate. Smooth muscle. All right. A long, kind of smooth, flows like a river look to this cell at the this tissue at the cellular level, and so this is smooth muscle tissue. You see a nuclei in here. Smooth muscle is in the intestine, for example. And skeletal muscle. These are when you think of your biceps brachii. That's made of skeletal muscle. When you eat, if you eat meat, not everyone does. If you do, you're eating skeletal muscle. Unless you're eating the heart, that's the cardiac muscle. Or if you're eating the liver, that would be a smooth muscle. So, ta-da! It's significantly. It's identified by its striation. So can you see the striping happening here? Striping, right? And that has to do with the way the cell looks and cellular development or tissue development. So skeletal muscle. Nervous tissue, beautiful electrical impulse unit, if you will, takes information in, synthesizes it, and decides where to send it, if at all. And this is an example of a neuron, and when you see it, you'll just write nervous tissue or neuron, but just write nervous tissue for number 20, and you'll be all set. So here's a quiz that you can practice with. Go down and say, what is this one? Write it down on a piece of paper. And that's, so if I pulled that up, I was like, number 1, you'll write down the answer. Number 2, write down the answer. Number 3, write down the answer. So that will be your exam when you come to class. And that's it. It's very simple. You'll have 6 epithelial tissues first. They'll be in a different order than presented here, and then you'll get into connective tissues. I will let you know that it's connective tissue. So then you will see, okay, I'm in the connective tissue zone. So I'm going to only answer the connective tissue answers, right? Going down. And then I'll get into the cartilages and you'll say, here's the cartilage. And these are the 3 cartilages here, right? And I'll say cartilage for 3, and then we'll get into muscles. You'll have 3 muscles to identify in a different order. And then the last one will be nervous tissue. So you can write down number 20 when you enter the exam. It will always be the nervous tissue at the end. All right, so that's how the exam works. I wish you luck and have a great day.